No, it does not have a camera on the recording. It's just audio.
I was gonna say people might be a little.
To be fair, when we were virtual, I did used to do theme weeks, and I definitely did do a Harry Potter theme week. I also did a Mario theme week, trying to get my algebra kids to watch the videos. I'm not entirely sure anyone actually saw any of the costumes I wore.
Oh, wow. Nobody said anything about it?
Not one.
What did they used to know?
I did Mario backgrounds with like outfits. I did Star Wars week where I did the Leia bonds, and I carried
Are you dressing up tomorrow?
I have my outfits for the whole week
You're doing
already
every day?
laid out on my dresser.
You're doing it every day?
Every single day.
Wait, for Friday, what color are you dressing?
I'm going to wear all of them because I teach all students. Well, it's red, black, white, and gray. It's pike colors. What's up?
It's my slime day today.
Huh?
It's my slime day today.
Your slime
My
day?
G day.
I don't know what that means.
What do you mean? It's my S day.
I don't know what that means. We're gonna move on from that whole sentence because I don't know what that means. That sounds gross.
Oh, that's what's powerful.
All right. So it's important for us to remember in our coordinate plane what our quadrants are. 1, 2, 3, and 4. Yes, where's 1? Right there. It has our positive x's, positive y's.
This is so fun.
And then we're going to have quadrant 2, which has negative, yes, it is 9/11. Negative x's and positive y's. I was actually here for 9/11
Oh, wow.
as a sophomore.
No, what? You went to school?
What happened on 9/11?
I was taking I-STEP.
All
Yeah,
4 years?
yeah. I'm in the Hall of Shame.
I'm gonna go find your picture.
No, I was not top 30. No, I was not even close to top 30.
On 9/11.
I took I-STEP and didn't hear about it until noon.
That's what I had last time.
We didn't have like cell phones and TVs and stuff. There were no cell phones, so none of us knew unless they had the TV
You know
on.
my birthday was on 9/11?
There's a lot of people.
Exactly, yeah.
Not a history class. Get the history teacher for more than that. I was in I-STEP when it happened.
Can you use your magic wand?
You may not. That's a very personal question. We don't share wands. I don't know. Now he's mixing things, trying to get me off track again. We were talking 9/11 and then we jumped back into Harry Potter.
Were you alive on 9/11?
I was taking I-STEP as a sophomore here down in the G hallway. Yeah, I went to graduated from here. The you know, at the bottom, like F and G hallway where it's the little loop where the English classes are. I was in one of those rooms taking I-STEP.
How much does the school change?
Surprisingly little.
We're so broke.
D hallway is wider than it used to be, which is weird and still messes with my head. Because you know all the silver posts in D hallway? Those used to be classroom walls. There was a set of classrooms up to those silver posts.
Are all these fancy symbols just 1, 2, 3, and 4?
Yes, they're Roman numerals.
Oh.
1, 2, 3, and IV. 1, 2, 3, and 4 has positive x's, positive y's, negative x's, negative y's, that kind of jazz. That's what those symbols mean. Okay, so we're going to remember which quadrant is which, how we can tell, and all that jazz. I'm not changing the page yet. Okay, because we are going to be graphing things today. I know, fancy schmancy. We're not always going to have to graph. We're going to graph. I think we're going to get like 2 or 3 graphs today. Maybe 1. Okay. Are we ready? So what we're going to do next is we are going to describe the set of points that satisfies the given condition. What the heck does x equal negative 2 look like? So if we think about it, like we can do a little sketch of it if we need to. I saw at least one person doing this, right? Because if I know it's Isaac. If x equals negative 2 is right here. Ish. It could be any y in the entire existence of the universe, right? So x equals negative 2 is a vertical line through negative 2. That would describe the set of points. It's a vertical line through negative 2. Or you can say a line parallel to the y-axis. How about y equals 3? What's that going to look like? A horizontal line through 3. So I'm going to word it a different way just so we can see it like all the ways it could be seen. A line parallel to x-axis through 0, 3. That's another way to word it.
But you don't have to put all that.
Nah. You can also do a vertical line, but just know that both of those work in case you see it the other direction. And I ask you to tell me about a line parallel to the x-axis through 0, 3. Know that that's the same thing as a horizontal line through 3. So we may have to be able to read it both ways. Therefore, I'm going to occasionally write it both ways.
Pardon the interruption, but today is an ADM roster count day. Get your rosters to the appropriate office.
No, put it on a Monday. Nobody remembered. It's a paper we have to print out and send down in second period. Not anything to do with you. It's how the school gets its funding and they make us do paperwork for it. Yeah, you know, right? All right. So let's look at C, where x is greater than 0. Where are the x's greater than 0? I heard lots of options there, but I couldn't tell what any of them was. Huh? Quadrant 1 and quadrant 4. Yeah. Anything over here. Any point in quadrant 1 or 4, which we do typically write them as Roman numerals. It's best math grammar. I'll get what you mean, but it's best math grammar. You could also say all points to the right of the y-axis. Let's look at D. X times y is greater than 0. First quadrant.
Fourth quadrant. No, third.
First quadrant and third quadrant. Any point where they have the same sign, basically. That's a P. There we go. Point in quadrant, which I will almost never write out the whole word quadrant because I can't spell it. 1 and 3. So I'm 100% okay with us saying quad because that's way easier to spell. Spelling is a suggestion. Quadrant, which I have to think quad pant. Just switch the P for an R. All right. And then our last one up here. What about y less than 0? Where's that going to be? 3 and 4. Is anybody... That's not the highlighter. That's terrible. There we go. You can also say any point below x-axis. You can also say quadrant 3 and 4. Those all are showing the right thing. So we're remembering these quadrants, trying to describe things with words, even if it's whole regions. Okay? Questions on these ones?
What is your favorite?
Quadrant
What do you associate with?
I associate with quadrant 1 because that's where most real world things happen.
How do you feel about quadrant 2?
I don't dislike quadrant 2. It's just when we owe people money.
Which is your least favorite?
I don't know that I have a least favorite quadrant.
Come on.
I know. I'm sorry, I don't have them. All right, we're also going to need to remember the distance formula. I know, we're trying to see how far off topic we can go.
No, I actually was interested.
Okay, totally fine. I'm glad you're interested. I don't have answers for those questions. I don't know that I've ever thought about a preference for quadrants. All right. They are inanimate concepts. I'm pretty sure they're fine. All right. So we're going to talk about the distance between 2 points. The distance between 2 points. The formula for that is, so A and B are 2 points. It's a take on the a take on the Pythagorean theorem. It's just been solved for C, where we take the difference in our x's, x2 minus x1 typically, and square it. Added to the difference in the y's, squared. It's the Pythagorean theorem, kind of. The reason for the squaring is it makes things positive. So that's why we have to square root the squares. And it's square rooting the sum of the squares. So it does make a difference when we deal with the square root. So what this is making A and B the 2 points. It genuinely does not matter which one is x1, y1, and which one is x2, y2. It doesn't matter, but that's what they mean by the distance between A and B. It's point A, point B, using the x's and y's from point A and point B. And we gonna practice with it. Okay. We're gonna work with this sum. So we're gonna find the distance in these 2 points. So I'm gonna write our distance formula again, because I don't have it on my page. Distance between point A and point B, we find with the square root, x2 minus x1 squared plus, you should have this on your page, I'm just writing it again so we can see it on the screen while we're working with it. And what we're going to do is we're going to take our points, take our x, take our y, and plug them in. So our distance equals the square root of 5 minus -3 squared plus 1 minus 6 squared. Plug in the pieces. I color code it so we can see which point is leading to which value. What is 5 minus negative 3? 8. So we have 8 squared plus 1 minus 6? Negative 5 squared. What is 8 squared? 64. What is negative 5 squared? 25. What is 64 plus 25? 89. What is an approximate decimal answer for 89, square root of 89?
9.8.
Yeah, and so it's somewhere between 81, which we know is 9 squared, right? And 100, which is 10 squared. Yeah, so it's somewhere in between. So one way you can get a decimal approximation, I'm sorry, just like putting symbols in so we can actually see what the heck I'm talking about here. How many steps are between 81 and 100? 19. And how many steps did it go? 8. All right. How many spaces are between 81 and 100? 19. How many spaces did it go? 8. The 81, I was saying what's the nearest perfect squares I know? 81 and 100 are 9 and 10. So the approximate decimal answer for the square root of 89 is 9 and 8/19. Okay, fractional.
Wait, sorry, can you say how you got the 19 again?
The 19 was between 81 and 100, the two nearest perfect squares I know. There's 19 spaces. Yes. The 9 is the smallest perfect square below it.
What about the 8?
The 8 is between 81 and 89. It moved 8 steps.
It's 9.
Yeah.
Yeah!
This 9 is the lower of the squares that I can think of. Okay, so we're not going to have to do a ton of that, but it gives us kind of an idea. We're going to do that. What's up?
I know you got the 89. Can you go through how you got the 81, 100, and then ended up with 9, 89?
So 89, the two nearest perfect squares I know. The perfect square below it is 81. Perfect square above it is 100. That's 9 squared and 10 squared. So I know it's somewhere between 9 and 10. That's where I'm getting this 9 from, is the perfect square that's below it.
Wouldn't it be 9?
And then how'd you get the 8 over 19?
This is 8 steps away.
Oh.
This is 19 steps away.
Alright.
Okay? So it gives us an approximation. It's not always going to be exact, but it's real darn close. It's real darn close. And that's a way to do that without a calculator, because we don't get those. And so when we're looking to estimate it, this gives us a couple of tools to have in our back pocket to get something. Okay. Ready for another one? Except it's a little different. Because we're going to be looking at 3 points this time and trying to see if it's a triangle, if it's a right triangle. And this is actually the only graph we're going to be doing. So I'm going to It's the only graph today. We will have so many more. If you have a graph paper notebook, like, you can absolutely use that, but if not, I will have graphs available for you guys. We're going to do more than one distance formula, because we'll have to remember what it means to be a right triangle as well. All right, there should be glue sticks in the little boxes on the table. There's scissors if you're not a fan of the way I cut them out. They're not stickers. They are paper that you just have to glue in yourself. I am bougie, but not that bougie. Stickers cost money.
Oh, you should get one of those little sticker printers. It's like mobile.
The problem with the sticker printer is the sticker paper is still expensive. And I don't got sticker paper money. I have free school paper printer that I can use, money, and a little slidey cutter that I have.
You have to choose my students, mother.
Huh?
Here's my students.
Oh, yes, I do.
Special.
I use it during finals.
I love it.
I just don't use it all that much because the vinyl is annoying. All right, there should be more glue sticks in there. I have more. If it's dead, throw it in the trash without actually throwing.
Wait, I got it.
I would have made it.
Because like my sanitizer bottles are all glass. Yeah, even trash ball legends miss. All right. So we need to plot our points. That we know how to do. A is -1, -3. So this is point. Whoa, holy chunky pen, Batman. So there's point A. B is at 6, 1. And C is at 2, -5. So we have these 3 points. And we need to prove it's a right triangle. How could we show it's a right triangle?
We can find.
A squared B squared equals C squared. Pythagorean theorem. I should have done Robin from the Lego movies so you can physicalize it. That's like my favorite Pythagorean meme. Oh, fantastic. So we're going to be using A squared plus B squared equals C squared to see if it's a right triangle. What's up?
Can't we just write a square in the end of it and say it's a right triangle?
You could say that, but that doesn't prove it. Whenever we say something like show, this means proof. You gotta prove it. You can't just say it. You gotta prove it. You gotta have math to back up your facts. Show means prove. Because I'm bad at spelling. Prove. There. You have to prove it.
Is that yours? Oh my gosh.
Okay. So what that means, A squared plus B squared equals C squared means I need distance for side A. I need distance for side B. And I need the distance of side C.
Oh, that's where we get it at.
So we need to use the distance formula between all the points. So we are going to do the distance between points A and B. We are going to do the distance between points B and C. And we're going to do the distance between C and A. That's a lot of distance.
You're a distance runner.
Okay.
Great job.
There we go. So we're going to bring it in and find the distance of A and B. That's the square root of 6 minus -1. So 6 plus 1 squared plus 1 plus 3 squared. So it gives us 7 squared plus 4 squared. 7 squared is 49. 4 squared is 16. So our distance is square root of 65. Is that one that we know? No. And we're going to leave it in square roots right now because we're going to be using it in Pythagorean theorem here in just a second where we're squaring everything anyway.
Oh, yeah.
So just leave it as a square root. So then we're going to do the same thing for points B and C. So we're going to do 2 minus, I'm looking at the wrong one, 6, yep, squared, and -5 minus 1 squared. 2 minus 6 gives us -4 squared. -5 minus 1 gives us -6 squared. So that gives us the square root of -4 squared plus -6 squared, 36. Square root of 16 plus 36, 52. All right, one more like it. Between C and A, 2 minus -1 becomes 2 plus 1 squared plus -5 minus -3 becomes plus 3 squared. Three squared plus -2 squared, which gives us the square root of 9 plus 4, square root of 13. So there's all our distances. I've got the distance of AB, the distance of BC, and the distance of CA. Which one of those do we suppose is our hypotenuse? AB. Why? Because it's the longest. So this is what we think is going to be our C squared.
What's hypotenuse?
The longest side of the right triangle. And give us some more space to write. So we think if this is a right triangle, that the square root of 52 squared plus the square root of 13 squared should equal the square root of 65 squared. That would be side A squared plus side B squared plus side or equals side C squared, right? Plug the pieces in. So what is the square root of 52 squared? 52. What is the square root of 13 squared? We want to know if that equals square root of 65 squared.
Ooh, it does.
Ooh, it does. So is this a right triangle? Yes. So it is a right triangle. This is proof that it is a right triangle. So then we're going to go back to the top and make sure we answer all the dang questions. Because next it asks us to find its area. I know. How do we find the area of a triangle? 1/2 base times height. So which one's our base? AC, which is what distance? Square root of 13. What's my height? BC. Square root of 52. So our area is 1/2 square root of 13 square root of 52. We gotta simplify this. Is there a way to rewrite 52 as a like product of something? Thirteen times 4, right? 52 is 13 times 4. Square root of 13 times square root of 52 gives us 13 times 13 times 4. So can I square root that? Take out pairs. So 1/2, we can take out the 13. Can I take the 4 out of the square root? As a 2. So what's our area? 13. Okay. All right. We'll grab the next definition, but we won't do the next solving. Okay? So our last of today is going to be for you to write down these definitions. And then we'll work with perpendicular bisectors tomorrow. I know. What?
We gotta write this down.
Yeah, you'll want to write this down because we're going to work with it tomorrow. We got 4 minutes left, so you guys have time to write it down. I'm just not going to make us rush through the problem on it.
Yeah.
So that'll save us the writing part of tomorrow, and we'll just hop right into. So a perpendicular bisector is a line that is perpendicular to a segment and intersects at its midpoint. The midpoint, remember that's half of the distance. The midpoint, if this piece is congruent to that piece. A perpendicular bisector goes through the midpoint and has a right angle. And the way we can test if a line is a perpendicular bisector is that every point is the same distance. No matter if we're looking at these endpoints, those guys will be the same. If we're looking at points kind of in the middle, those will have the same distance. Every point on a perpendicular bisector has an equal distance to the endpoints. And we will play with those tomorrow looking at perpendicular bisectors.
Nah, we need
Because if they're the same distance, all we gotta do is find the distance between the point on the midpoint and the end points. So it's all using distance formula. So 2 minutes to the end. Oh, I should hand you guys out the homework sheet.
We have a homework sheet?
The scheduling thing. Yeah, I made it bright yellow so you could find it this time.
Oh,
Because I had a lot of people
I did not
lose
find mine.
last chapter, so I made them very, very bright so you don't lose them. So this has all the homework problems for this next chapter. Our next chapter test is on Friday, October 6th, which is the Friday before fall break.
It was something like that. It was kind of hard.
It's hard to get home. That is what they're saying. Is that
Unit test is October 6th. Yes. You can either come after school or you can come during the 5th period and take the test.
You know, because I know you have a bunch of shows, so I don't want to come in.
It's my prep period, so you can come anytime.
Okay, anytime. Okay, so I'm thinking Tuesday because I have work today.
Okay.
So Tuesday, all right with you?
Tuesday, 5th period is fine. Remind me tomorrow and I'll write you a pass.
Gotcha. Because I have work based on like classes as well.
Okay.
Business class, I can just come in.
Okay.